Now let's see what happens when we have a geometric series. There's two formulas for geometric series. One is finite, which means it ends, and the other is infinite, which means it doesn't. They want us to find the first 7 terms of the following series to the nearest integer. Okay, well that's finite. So we're going to be using this one right here, this a sub 1 times 1 minus r to the power of n over 1 minus r. Okay, so a sub 1 obviously is the first term. So in this, the first term, let me do that here, is 29. 29. Get the rest of that down. Can't keep up with me today. There we go. All right, what about the r? Well, the r we'd find by dividing 174 by 29. Let's see what that is. 174 divided by 29. That's 6. And the other one will probably be 6 too. I'm just going to do it just to be on the safe side here. We got 1044 divided by 174, but that's going to be 6. Yep. Okay. So the r is 6. Let's just highlight that. Not that r. Okay, there we go. And then lastly, we need the n. The n, they tell us, is 7 terms. Okay, that's told to us right there. So that's where we're getting that 7 from. Okay, now let's plug this in. We got 29 times 1 minus 6 to the power of 7 over 1 minus 6. Okay, this is definitely Desmos time. All right, so we got 29 times 1 minus 6 to the power of 7. And we're going to put that all over 1 minus 6. All right, 1,623,623. So that is going to be the sum of the first 7 terms of this geometric series. They want us to find the first 8 terms, or the first sum, or the sum of the first 8 terms in the following series to the nearest integer. We get 18, 12, and 8. So in order to figure out the ratio here, all we have to do is, oh my goodness, come on, 12 divided by 18, which is going to be 2/3. Okay, so the ratio is 2/3. Common ratio is 2/3. Then we would say we'd have to get the number of terms. The n value in this case is 8, and the a sub 1, they tell us, is 18. Okay, time to plug this into the finite geometric series formula. So a sub 1 is 18. We're going to multiply that by 1 minus the common ratio, which is 2/3, to the power of 8 over, now look, this looks like a 10. Let me make that an 18. And then that's 1 minus 2/3. Again, this really seems like a Desmos problem. So I'll double check. Okay, 18. 18. So we got 18 here. This was now 2/3. This was to the power of, oh, I forgot. Let's see. 8. Power of 8, all over 1 minus 2/3. All right, so that's going to be about 51.9. And I think I want it to the nearest integer. Yep, so nearest integer is 52. So this sum of this series is around, I should put that in there, 52. Sometimes you'll get some problems that look a little tougher, and I wanted to do one of these. So we got 3 9/4, 27/16. It's the same thing that we did before. We would divide a sub 2 by a sub 1, which would be 9/4 divided by 3. Okay, so what would that look like? 9/4 divided by 3 over 1 would be the same as 9/4 times 1/3. So in this case, we could cross reduce here. That would be 3/4. So that means that the ratio here is 3/4. And all we'd have to do, once again, is plug it in. The a sub 1 is 3, right, times 1 minus 3/4. It says 8 terms, so to the power of 8, all over 1 minus 3/4. Again, let's go to Desmos. Okay, it was 3 here. Oops. 1 minus, and then this is 3/4 to the power of 8. And this is, of course, going to be 3/4 as well. All right, so the nearest integer there is going to be 11. So the sum of this geometric sequence is around 11. Okay, please try this one on your own, and then when you're done, you can unpause and I'll have my solution. Okay, your a sub 1 is 28, your common ratio is 4, and the number of terms is 6. So when you plug that into Desmos, I get 38,220.